Okay, so I'm just coming to our discussion where we stopped, and then we will continue. Please, one suggestions for you is that you try to first clarify what is the application. Application, if you don't know how to use, then this knowing statistics is really not much useful. So I'll take the example. We have already shown you how can you really solve these kind of problems using your Excel itself, and how the manual calculation is coming into picture. So if I simply say from this slide, I think my screen is shared, right? Yeah.
Yes, sir.
Okay. Yeah. So what we finished in last class, only this is the case. If you forget the background every time, it is really not possible for everyone to memorize what is the background everywhere. But at least the application part, if you know, it's fine. What was the application here? And we will move a little bit more. Our objective was, we are doing something in a lab, some analysis we are doing in a lab in multiple sets, maybe some 5 or 10 replicates you are doing. And normally what you normally do, you simply say the average. That's only you do, right, until now. But from now onward, using this one, t statistics based analysis, only this part you will be using. We will be talking about what is the confidence interval for some region. So I want to know what is the 90% guarantee, in between which range your mu is likely to be there. So when you will write now onward anything on your data analysis, you have replicated something, you are reporting, please focus on that. So this is the approach we are going to do till now, and we discussed other of course z distribution. I already told that it is little bit problematic because we really don't know sigma square, and I cannot use that. In second case, we are using sample standard deviation. That's all. How to see the t distribution table we have talked last day, so I cannot really repeat it once again. So that was the thing. So I'm having some samples, and your role by this time, you only know how to talk about their confidence level. So you'll calculate the mean, and you will say plus minus this much, for example, plus minus 0.315 at 90% CI. Only this thing you could now tell. So this is very important in statistics, but that is not sufficient. We need to know something more. And today we'll be talking about another thing that is known as hypothesis testing. Okay, hypothesis.
Sir?
Yes.
Sir, Shakti wants to join the call, sir.
This is, I don't see anyone is requesting here.
Sir, just now joined, sir.
You joined, right? Yeah.
Thank you. Oh, yes, thank you, sir.
You see, we are talking about now on hypothesis test. What is this means? Let me tell you one simple thing. For example, assume that normal heart rate, for example, I'm asking one simple way to understand. Normal heart rate is, for example, 72. We know. Okay. And not only that, we also have some information on its variance also, possibly. Maybe, for example, population things are known. This is the normal heart rate of population. Now, if I ask someone that, okay, I am having some sample, now we will ask whether this value, or maybe my sample's value is greater than the population average or not. So now, earlier what you are doing, we are only talking about the label. So mean plus minus something I was telling. But now we will not say like that. We will say whether the value is greater than 60 or not. So for example, let me another simple example. So for example, I'm telling I'm taking some 10 individual and I'm measuring their heart rate, 63, someone is giving 75, someone is giving 76, someone is giving 74, and someone is giving 60, like that. I measured these things from population. I mean to say, my 10 students in my class I'm measuring. 10 is very small, but assume for time being. Then if I ask you, or maybe someone asks you, from this, can you tell that the heartbeat is less than 72 at 90% level? That means earlier at 90% level I was telling you the range, but now we are telling that okay, heartbeat is, or maybe the population heartbeat is less than 72. I'm speaking like that. Is my comment true or not? If I say like this way, question is just little bit changed, nothing new. Hypothesis test is actually we assume something and do analysis. Hypothesis test, what is hypothesis? You already know for research. We will assume something, okay, this works on that. So based on that, if it works, what happens? If it does not work, we may be saying that hypothesis is accepted, hypothesis is rejected. So there is two way of doing a hypothesis test. We'll put a question, we'll put a comment, and we'll validate. How to validate? Now, simple way. Anyway, if you read the textbook, and I will talk later on, it will be a little bit complex. Now, what I am asking here is that, can you tell that heartbeat is less than 72 at 90% guarantee? What does it mean? First of all, try to understand when I am talking about less than 72 at 90% mean. So this is the question. I have to respond by yes or by no, right? That is I am waiting for. How to do that? Because you cannot do, you already know this. Now, listen carefully the steps, the fundamental steps. So if I tell you that this is my sample data, and if I ask you to make a distribution, and if I say, from that you know how to make, how can I speak about, how can I speak about this mu, right? You last time you already remember that we can do using plus minus that. That is both side limit. Now if I ask you, I want to know, okay, if I only want to know the left side of the 90%, I mean to say the whole area below which 90% is there. So this is actually, you are talking about a distribution, and I want to look for less than 90% from my statistics. I think, are you getting my point? No. Yes or no?
Little bit yes, little bit no, sir.
I'll just repeat once again. So for example, I want to look for things which are falling below this area is, for example, 90%. Then I want to say, for example, in case of T distribution, so T alpha by 2, and this is area is alpha by 2, for example, and this is 90% I am looking for. So for example, if it is a T distribution, for example, if I know, and I know this area is 90%, then I can say that anything, or I can say T is less than T alpha by 2 at 90% guarantee. So my question coming again to you is that, so if I know this point, what is this location in T distribution scale? If I know the location, then I can say yes, it is less than this value with 90% guarantee. Now I am talking about 72, right? What about 72? So now question is that if 72 falls within this range, if 72, by the way, if it falls like this, not 72, actually We have to normalize that I'm talking later. So if 72 falls within this zone, so can I say that yes, 72 also, so I'm talking about less than 72 with 90% guarantee. If it is false like this, can I say? No. For example, this is 80. So I can say, let write the comment very clearly. I can say, for example, BP is less than 80 at 90% guarantee. Why I'm getting from my analysis, because 90% area, for example, falling here, this value is, for example, 80. Then I can say blood pressure less than 80 at 90% guarantee. That I know. But I asked less than 72 also. So is it possible if the blood pressure for some population at 90% guarantee, I can say it is less than 80? Can I say the same time that BP is less than 72 at 90% guarantee? Can I say? Yes or no?
Yes, sir.
No. You have to understand this logic clearly. Let me tell you one thing. I am telling that you will get less than 80, 99% confident you will get less than 80. I can be fine, no issue. But if I say you will be less than 50, 99% confidence, can I say like that?
No, sir.
No, na? So same thing. You see, that means I am talking about lesser value left side. That means my hypothesis will fail. If I say, if for example, somehow you can guarantee this is achieved, and then I am asking, I'm getting that at 90%, blood pressure will be definitely less than 80. Now, if I say, if my question was like this, if my question was that, okay, blood pressure is less than 90 or 85, so can I speak that BP is less than 85 with guarantee? Yes.
Yes, sir.
Because it is beyond this. I can always say, without knowing anything, that your marks will be less than 99. Yes or no, in your exam? And that is a high confidence. I need not know my student for that. So anything higher side is always easy to predict. Now, from where these points are coming into picture, we will be going into our hypothesis. This I will not discuss now. I will come a little bit later. Oh, this was actually whole statistics. So here. So there is two way of talking about hypothesis testing. We have to talk about the hypothesis first, and then we will go for statistics. Now, all the things you need not read. I will come very soon. Here. Now, question, for example, this thing you already know, that probability that this is, for example, I'm talking about a normal distribution, two-sided confidence interval we are talking about. So suppose x1, x2 is the sample. So if it is the case, then can I say that probability that my z will be less than this in 1 minus alpha. So z alpha is this. So this thing we have already talked. I am not going to speak on that. What does it mean? This thing, have you noticed? Okay, I think you are not very clear what I'm going to say. I need more time on this. Assume we are going to make a hypothesis test. There are many hypotheses we can put. I am putting a hypothesis that my sample mean is going to be greater than some value or less than some value or within some boundaries. So basically, you need to understand when I'm talking about a limit or two-sided test, if I'm going to do, I can always say that my value, for example, in case of Z, this we have already done. This is nothing new. But this time I am doing a little bit different way. What I am doing, I am saying mu minus x things is greater than this one greater than this one. That I can say. What I'm trying to mean is that mu minus x will be always greater than this value and smaller than this value. So mu minus x limit I am going to find. Now, why these questions are coming? If this question is coming, then we already shown that mu will be greater than this and less than this at 90% confidence level. We already talked. Now, if my hypothesis is such a way, if I am saying, okay, there can be three different. I think I should give a little bit different way. I should speak. I'll come. First, I am coming to the hypothesis things. From this slide, I will actually start. Otherwise, it will be little confusing to you. What is the confusion? Confusion. There is three kind of hypothesis tests are there. One is, okay, from my few values. Sorry, for example, I'm having some few values 50, 60, 70, 80, and 90. We are measuring. Then I'm saying, okay, my population mean will be, I'm telling that my population mean will be 72. If I'm making a comment like that, so there is two hypotheses is involved. First hypothesis is, okay, you assume that, okay, this fellow is telling correctly. I mean to say, this is my data and I am putting a hypothesis that my value is population mu will be 72. I have to validate. There is two hypothesis point of view. One is known as H0 null hypothesis. This is called a null hypothesis. And alternate one means it is not. So basically negating the other one. So negating the other one. Now there is a test approach. What test I can do to validate this? So validate this approach when I'm going to do, you just see one simple things here. Yes. Now, for example, I told I'm having the 5 data point, right? I'm having, for example, 5 data point and 50, for example, if I say 50, 60, 70, 80, and 90, this is my data. And I am telling, okay, my population mean is mu equal to mu, that I'm testing mu equal to, for example, 72. This is my test. It is not really, try to understand. I am testing that, okay, mu equal to 72. Now question is that whether this comment is correct or not, that I have to tell. How can I tell that? Very easy. First of all, you forget that you are doing a hypothesis testing, first of all. Now, if I am not doing hypothesis testing, you already know that I can find out the confidence level simply. This one you have already done. X bar plus Z alpha by 2 sigma by root n, X bar minus Z alpha by 2 sigma by root n. So forget this hypothesis part first. You keep it aside. Don't see it. Don't see my question. You see, I'm asking you, tell me the confidence level. So from this data, I think you should be able to tell me, for example, you are telling average of this is, for example, average is coming 50, 60, 70, average is coming 70. And this plus minus you are doing, na? You are telling, sir, with 90% guarantee, I can tell that my value is coming plus minus 5. You are telling like that. That time you forget that this is the question. If this is, you forget, what does it mean? You are telling that your mean should be within 70 plus minus 5. Try to listen me carefully. That means it starts from 65 to 75, yes or no? Can you please speak out?
So could you repeat the statement again, sir?
Yes, I am repeating the statement again. Question is that, for example, you got some 5 or 6 data point, experimental data, then we are doing a hypothesis test. Someone is telling that you know this is the data and your population mean will be 72. Someone told you. Now question is that there is two options. Either you have to tell no, you are completely wrong, or you have to accept it. So if I accept it, so forget about this hypothesis part. For example, I am not asking any question. But if I don't ask you any question, can you tell me with 90% guarantee where the mu should be there? Yes, because this thing you already know. X bar plus minus Z alpha by 2 sigma by root n, that you already know, that I can calculate from these samples. And I'm finding out that my mu value is within 65 to 75. You have done it side by side. And now you're coming to the question. Now we'll say, okay, tell me what you are asking. And then he will tell, sir, I was asking that mu is 72. Is it correct or not? Am I very wrong? Then what you will say? No, you are not wrong. Because you are also telling the same range, 65 to 75, where 72 definitely falls in between. Yes or no?
Yes, sir.
Okay, so try to understand how we are testing. We are testing a little bit different way. We are testing whether if my criteria is fulfilled, this I will normally do like this. And then I will come to your question little bit later on. And I will see if this fellow is telling 72, is he doing very big mistake? I find no. Actually, I am also telling with 90% guarantee that they will be within this. So if this fellow is telling that 90% guarantee 72 within this is fine, it is fitting. So that means I can really speak on that. The same thing they are doing, they are not doing anything else. Okay, they are just writing in a different way. What is the writing way? You can also see a simple way of writing. They are actually doing this statement, they are just reorganizing. Root n by sigma x bar minus mu 0. Mu 0 means your test part. We are testing with 72. So what they are doing just reorganizing. If this is the true case, I can just reorganize. And this is the point. Am I clear? It is nothing new. Understanding is only this part. So if I can calculate and if I want to validate, I can do the validation very easily. So this is the hypothesis test we are going to do. How to test? They are telling you first calculate root n by sigma from here. Root n by sigma minus this one will be okay. If you want that how I am getting this, I can write it out, but this is not required actually. That's why we are not showing all calculations. For example, we are doing like this. Okay, now if this is the situations, this one minus this is greater than this and this, I can just reorganize. What is the reorganization we are doing? We are actually multiplying. Okay, one step, if I just write this point, until this point there is no hypothesis testing. You already know this. Now we are doing another point. So instead of this, for example, I'm multiplying root n by sigma. So I can say Z alpha by 2 is greater than mu minus x bar into root n by sigma is greater than minus Z alpha by 2. Same comment, right? Just multiplying. The same probability, all those things will be unchanged. Equal to 1 minus alpha. This way I tell it. Now, for example, Z alpha by 2 is 3.7, for example. And minus Z alpha by 2 will be minus 3.7, for example. So basically I am telling that this value is within 3.7 minus 3.7. Yes or no?
Yes, sir.
So I am telling that this value is within plus 3.7 minus 3.7. And now I was testing what? I was testing mu 0. Yes or no? So if mu 0 fitting also, if I put mu 0 and I calculate, if this calculation also comes within plus 3.7 minus 3.7, then I will assume yes, it is okay, no issue. Am I clear? Instead of mu, if I put mu 0 and then also it is valid, that means okay, problem is solved, no issue. So that means what I'm trying to say, I will accept it if it is within, for example, z alpha by 2, z minus z alpha. Now can you tell me minus 3.7 and plus 3.7, in between that anything, any number is coming, what is its property? Any number in between minus 3.7 and plus 3.7, can I say, please listen very carefully, can I say that absolute value of that number, absolute value of whatever number I am telling, will be less than 3.7? Yes or no? You tell me. In between there is some, if you don't track my wordings clearly, it will be difficult. Now I understood that within minus 3.7 and plus 3.7, this value, if it is coming, my hypothesis is true, no issue. But I'll say now another one statement. In between minus 3.7 and plus 3.7, any number you assume, in between minus 3.7 and plus 3.7, can you tell any number? Minus 1, yes or no? Minus 2.
Yes, sir.
So if I say absolute value of your guess number minus 2, it is less than 3.7 or not?
Yes, sir.
If I say plus 2.5, absolute value of plus 2.5 is 2.5 only, it is less than 3.7 or not?
It is, sir.
So what I can say, that everything which is falling in between minus 3.7 and plus 3.7, if I take an absolute value, I can simply say less than 3.7, my job is done. So what I'll say, this was that part. Na? So I'll say absolute value of mu0 minus x bar root n by sigma will be less than, instead of 3.7, I will say z alpha by 2. That is only written, you see, that is the only written things here. I'm sorry, I have written already. So it is nothing new statement I am making. They also made a statement like this. So if this is the case, what will happen? If this is the case, mu0 satisfied, then hypothesis cannot be rejected. So I have to accept the null hypothesis. Are you clear about my statement now? You have
Yes,
to
sir.
accept the hypothesis. Yes, this is true. This is the hypothesis test. If it is not, then I will say the null hypothesis is rejected. That means I cannot say what you are claiming, I cannot validate that. This was the point of discussion when I'm talking about confidence interval of the things. Now, that is, you see, this is only about this part. Now, if I make, what kind of hypothesis test can come? Now, if I say hypothesis means, it's like satisfying one fellow who is asking so many questions and you want to solve him out. Now, before I go further, hypothesis test is nothing a difficult job. It is only two questions we are putting. One is called null hypothesis, another is called alternate hypothesis. Null is like, what is null? How can you validate the hypothesis? Validates an hypothesis. For example, this was the question. Na? First question was that, okay, I gave you 50, 60, 70. I'm maintaining the same question. 80 and 90 is the 5 reading of 5 individual. Then we are saying someone is claiming that population heartbeat is 72. Do you agree with that? That means they are asking me to say yes or no. So what I will assume? I will say, I'm assuming one time yes. I'm saying yes. That, sorry, the mu is really 72. I'm accepting that. And second time what I will say? Null hypothesis. No, mu cannot be 72. This is two questions. Normally we validate whether mu 72 is true or not. If it is not true, then I will assume this is true. So that is the hypothesis. This is called null. This is called alternate. Okay, this is fine. And this time we only asked a question of 72. But I may ask a question, maybe I'm a little bit more tricky fellow, and maybe I'm asking, Can you tell me that the population mean, now question is different, population mean is less than 72. So now I am not happy only with 72. I also need you tell me that it will be less than 72. I want to know. So that means this is my question. And what you have to do? This time I will assume, okay, my null hypothesis is 0. I will assume that mu is less than equal to 72 is my one question. This is called mu 0, the testing value, na, whatever exact number you are testing, that we normally refer as mu 0, the test value. Okay, just for understanding I am talking. Alternate hypothesis is, for example, I am asking what will be the alternate? Mu will be, what is the alternate option remaining? Mu is less than 72. Alternate is mu is greater than 72. So I am making two statements. I have to validate. So I will try to validate whether this is true or not. This is my intention now. Now coming to the slide. So now, for example, I am asking, we have to verify, you read very carefully my comment. We have to verify that my population mean is less than equal to 72 at 90% confidence level. This is the question. My question is clear?
Yes, sir.
Yes or no? Do you understand?
Yes, sir.
This is the question I want to verify. So I will see how can I verify. Now you see, I am doing some changes. I am maintaining the same question, but I am just a little bit changing so that you will understand a little bit more. I mean to say, for example, I am testing mu is less than 72. Is it not equivalent that minus mu is greater than equal to minus 72? Yes or no? Anything minus if I do, na, the arrow symbol, positive or negative symbol will change. You know it this or not? Your silence makes me
No,
really
sir.
no. Okay, then you at least say. For example, if I say 5 is less than 9, can I say minus 5 is greater than minus 9 or not?
Yes, sir.
So what you understand, what I'm doing, why I'm doing the trick, there is a reason, but I'm just assuring that if I change symbol both sides, then the less than will change to greater than. That's my point of discussion. You verify any number. For example, 8 is greater than 5. Yes or no? True. But if I say minus 8, then I'll put less than minus 5. Yes or no? Correct? So you see what I am doing. Instead of this, I am putting a minus sign and changing the symbol and remaining the question unchanged. So this was not really difficult to understand. Now what I am doing, you listen carefully. From this, can I write this? Yes or no? If you don't agree, you let me know. My point was minus mu greater than equal to minus mu 0. That I am going to test. I have not tested. I have to verify. I have to verify. Now what I am doing? I have to verify if I can do, if I multiply root n by sigma, is this thing will change? You see the same picture. This minus this, same way, na? So if I root n by sigma, my question remain unchanged or not? The equivalent operation, and you are so silent on this. Oh, no response, right? You are switching off the mic so fast. Minus 5 greater than minus 9, for example. If I multiply by some number, the relationship will change or not? Tell me. If I multiply by 3, do you think the relationship will change?
No, sir.
So we are doing the same thing, na? root n by sigma. If I multiply, I'm still good. Now, if I add some number, positive number, for example, I'm adding some 70, both sides. Do you think adding something will change the relation?
No.
Okay, so that's why my point was minus mu was greater than mu 0. That I want to validate. It is not true. I want to validate that. Then I am multiplying with root n by sigma. So my symbol will not change. Then I am adding x bar root n by sigma, both side. X bar root n by sigma. This symbol will be nothing wrong. This is same thing. So basically they are organizing now. Root n by sigma. Can I say x bar minus mu greater than root n? So that's why I have written here. You see, nothing new I have not written. Root n by sigma x bar minus mu greater than this. So if you understand this quickly, I can move. Otherwise, my movement will be really very slow. So this is actually verifying this. Just changing the question. It is not solving. Now I am saying, is not it? So what does it mean? We mean to say root n x bar minus mu by sigma. What does it mean? This is z value, right? This is z. So we are verifying probability that z, and this is called t statistics. So we have to verify whether z is greater than ts value or not. Z means I'm telling root n x bar minus mu by sigma. I have to verify with that one. And this is called t statistics. If this is z or not, it is z distribution or not? Tell me.
Yes, sir.
Because this mu, what is this mu? This mu is real mu. I don't know, but this is actual mu. And this mu 0, we are testing. So x bar minus mu 0 by sigma is not any distribution. So instead of that, I am giving a term of this. Its name is just renaming z. So we are actually verifying whether z value is greater than ts or not. If z value is greater than ts, then I will accept it at 1 minus alpha confidence level. So now I have written so many. I'll just write up a part, I will delete, then I'll come back. Otherwise, I think I have written this, right? So coming over here. So I was until this point. So if my probability that my z distribution value is greater than ts at 90% or whatever guarantee, if it is greater than ts, I have to verify. If ts is greater than z, then I will reject. Please listen. Please see that carefully. So I have to verify whether my z value is greater than my test value. What is test? This one. Are you getting this point? At 1 minus alpha level, if I can validate if my z is greater than ts, if I have to verify. So how can I verify? Ts value can you find out? If I am telling you, you can find out the ts value. Because you already know x bar, because you are having 5 sample now, 1, 2, 3, 4, 5. So you can find out x bar, yes or no. And I have already asked you one question. My question is that less than 72, for example, I was asking. That means you already know mu 0 equal to 72. I'm asking. Sigma value also probably you are known. That means and root a number of you know. So basically we are asking you whether probability that z will be greater than ts. What will happen? I just change the symbol. If I say ts is greater than z, then what will happen? I will reject it. If the opposite thing happens, then I will reject. So what is the final comment? I will reject your hypothesis if my t statistics value is greater than z. If my ts value is greater than z at 1 minus alpha level. How to see this? Now you see, this is my z alpha value. This is alpha. If it is Z alpha, then this area is normally alpha. The remaining area is called 1 minus alpha. What is this question? From this, what can I say? I can say any Z. Can I say that Z equal to less than Z alpha at what confidence level? This area confidence level. Everything is Z. So same thing we are talking here. So if I am talking like this way, we can say, we know that Z alpha, now same comment, Z alpha is greater than Z. Same way. So instead of that, I can say Z alpha is greater than Z at 90% confidence level. Now, if TS is greater than Z alpha, if TS is greater than Z alpha, what? Okay, are you? I think you are going away from my all discussion. Let me come to some example. For example, this is Z, and I am telling that Z alpha is greater than Z. It is for any distribution. So, for example, Z alpha value is 3 or 2.5, or no, why 2.5? Assume 1.98, and this alpha is, I know this is just Z distribution. So from that I am telling that probability that 1.9 is greater than Z, I can say with 1 minus alpha confidence level, because this is the distribution table. I have nothing to speak on that. And I am here, what I am here? I am here that TS is greater than Z. If my TS value is greater than my Z value, for example, this Z value, then I will reject. Because you understand, I have already done this. It is nothing new. Now, TS you are calculating because you know X bar, you know mu, everything. So, for example, I am finding TS value is, for example, 2.7. Now, what will happen? I am asking now this two things, TS greater than Z. So, I can now listen very carefully. What can I say? I can say very clearly that 1.9, listen very nicely, 1.9 will be greater than my Z distribution. 90% guarantee that my Z will be more than 1.9. And here I am asking that 2.7 is greater than Z. Can you tell me? Now I am saying 2.7 is greater than Z. Are you happy with that? Are you ready to accept it? 2.7 greater than Z. Are you will accept that or not? I am finding 1.9 is greater than Z. Now you listen, you can visualize, then only you can see. I am telling 1.9 is greater than Z. 90% guarantee that 1.9 is greater than Z. Or other way, my Z is actually less than 1.9 most of the time. Okay, my Z is most of the time less than 1.9 actually. Same meaning actually. 1.9 is greater than Z means Z is less than 1.9, right? It is the same meaning, na? And now I am verifying if 2.7 is greater than Z. Is it possible? Because Z I am finding most of the time it is less than 1.9. And 2.7 is greater than Z. This I have to validate. What do you think? It is rejected or accepted? Anyone can comment?
Rejected, sir.
So you understand that I'm most of the time we are validating, first thing you are validating from Z distribution. And I can always say that probability that Z will be less than 1.9 is very high, no issue. Now I'm asking that Z is greater than, or I'm just verifying this one, for example, Z is greater than 2.7. Z is greater than 2.7. Is it possible to be true? No. Most of the time I'm finding Z is less than 1.9. 90% cases I'm finding Z is less than 1.9. And how can I claim that Z will be greater than 2.7? Who will accept that? Nobody will accept. So I have to reject it. So basically, this way comparison is done. It looks very for understanding, I'm telling you, but later on we will simply use the formula basis. Otherwise, every time you cannot really go and check. So hypothesis is coming like this way. So now this thing is all over. So I know Z alpha is greater than Z 1 minus alpha. If TS is greater than Z alpha means this 1.7 I was telling, na? Or T is greater than Z, reject hypothesis. Am I clear? If TS is greater than Z, I mean to say Z alpha, right? I'm not saying simply Z, I'm not Z alpha. So if this is the case, you can always talk about this point of view. So if this TS greater than Z, reject H0. So I need to know, I need to calculate the same statistics every time. I will reject the hypothesis that mu is less than mu0 when my T statistics value is
Your voice is breaking, sir.
Sir, we can't hear you. Your voice is breaking.
okay. So we'll be just finishing now. I think now it is visible, right?
Yes, sir.
Okay. So we are going to verify whether Z is less than TS, and for that we will reject H0 if TS is less than Z. TS is less than Z. So you see, TS is less than Z. So we are here, for example, minus Z alpha, this is alpha, this area is 1 minus alpha. For that, what can I comment? For that, from this graph, I can comment that minus Z alpha is less than Z statistics. I can comment. So this is known. Minus Z alpha is less than Z. And we are asking if TS is also less than Z, then we will reject it. So how can I, so this information is available to you and you have to make a statement. How can I reject or accept? So we already know that minus Z alpha is less than whatever I'm looking for. And we are looking that Z is less than TS. What is the possibility? This is all, listen very carefully. This is definitely true. It does not require any test. And Z is less than TS. If this is true, for example, if this is true, I'll just give you one very simple thing. So I'm saying Z is less than some number, and then I'm telling some number is less than that number. If both are true, what will happen? Simply assume Z is less than 20, for example. This I'm testing. And for example, I'm saying minus 5 is less than z. That is true because it is a distribution things. This is always true. So my test things will be correct only if, can you tell me what is the relation will come? Minus 5 is less than 20. If this is the case, then my point is always valid, or simply I can say minus z alpha is less than this TS. So same way I'll test. You see, minus z alpha and TS, if this thing is happening, then I will reject it. So the same process I'm going to talk. So TS is going to be less than z alpha by 2 if statistics wise value. So this is going to reject the hypothesis. Now we are coming into the last part of the decision. You see how to validate. This is the question. This is the values. We will reject this one or we will accept it. So we will reject the null hypothesis if my t statistics value is greater than z alpha or minus z alpha. So three problem is, now you can solve any problem. How can you solve this? So this question, what is the my question here? I can say somebody asking that mu is less than 72. This question you have to respond. That means I'm asking this. Alternate is mu is greater than 72. How can do that? I'm having a formula, that is the TS. You have already seen. TS means root n x bar minus mu 0 by sigma. What is this value? You already know. I'm having this value, right? 1, 2, 3, 4, 5. 5 is the number n. Average is 70. Mu 0 is what I am testing with. What I am testing with is known as mu 0. So mu 0 is 72 divided by root n. I'll calculate it. That is called TS. Then I will say if TS greater than Z alpha, that I have to find out. Z alpha value, because I already know from my T distribution table what is Z alpha value. So for example, this is Z alpha. That means this area is alpha. Okay, this area is alpha. So I can definitely find out from my T distribution table what is the value of Z alpha. I can find. Now you know TS, you know Z alpha. If TS is greater than Z alpha, I will reject. If TS is not greater than Z alpha, I will accept. So anyway, so this thing, these derivations we have already shown you. This we have done assuming Z statistics. I need not tell you that, okay, Z statistics is not really applicable because the sigma value is not known most of the time. So we can go for T statistics also. The same thing we will be doing when I'm going for T statistics. Instead of this sigma, my value will come as standard deviation. That's all. Other things will remain unchanged. Instead of Z, I will say T. Okay, instead of Z, I will be talking about T. So that's all new things we are going to utilize for estimation of confidence, hypothesis testing. Hypothesis testing is that way we can complete. Anyway, our time is over and you are all silent, so I'll stop it here. I can find only 12 people. Who are the other people who are absent? Likit, who are absent? Can you hear me?
Yes, sir. Yes, sir. I can hear you, sir.
Yeah, please let me know the absentees.
Yes, sir. Fine, sir.
I think total number is 14. 14 minus myself, 13.
13, sir.
13. Who are the remaining one? You just let me know. Okay.
Yes, sir. A few of them joined, sir, but in between, I think they had some network issue and then automatically expelled out.
No, I think it's fine now. You just let me know.
Yes, sir. Fine, sir.
Mhm.
So for the third internal, what will be the things internal?
Except this today's class.
Okay.
Except this today's class. T distribution, T alpha, Z alpha, these basic. I will not ask any questions from the table, right? I will not ask. I will simply say, when I say T alpha by 2, what is the area of T alpha by 2? Right side or left side of this area? That kind of questions. So
sir.
if I'm having the graph of T distribution and know what is the meaning of T alpha by 2, you can tell. Okay?
Yes, sir.
Okay, fine. And some questionnaires, okay, let me tell you. Some questions will be from your plagiarism, that slide we shared, na?
Yes, sir.
Yeah, so few questions will be from that. Not
So
much.
total
but few.
25 questions, right, sir?
Yes.
Okay.
Okay, fine.